There are two methods to solve exponential equations. One is using the same base and the other one is using logarithms. So when you have an equation, how do you know which method to use? The first thing you do is you look at your bases. Can you get the same base on both sides of the equation? If yes, then you solve the equation by rewriting with the same base and then setting exponents equal. If you can't get the same base on both sides, then you take the logarithm of both sides and then solve the equation. Let's solve these two equations to see the difference. In the first equation, we have the bases 9 and 27. They are not the same, but can we rewrite 9 and 27, for example, as a power of 3? Okay, let's go ahead and do it. Okay, so 27, it is 3 times 3 times 3. So it is 3 cubed, and then raised to the power of x minus 2. How about 9? 9, it is 3 times 3, so it is 3 squared, and then raised to the power of x. You see, we were able to rewrite these bases as a power of 3. So we got the same base on both sides, and we solved this equation using the same base. We're going to do it in just a minute. Now, let's look at the second equation. Well, right now, we can't tell if we have the same base because we have negative 3 in our way. Let's go ahead and add 3 to both sides in order to isolate the exponential term. What we will have? We will have 4 to the power of x plus 1 equals 15. Okay, our bases are 4 and 15. We can't rewrite 15, for example, as a power of 4 because 4 squared is 16 and here we have 15. We can't write 4 and 15, for example, as a power of 2 or as a power of 3, so we can't get the same base on both sides. What we're gonna do, we're gonna use logarithms. We're gonna take the common logarithm of both sides and solve the equation. Let's go ahead and solve these equations to see how both methods work. This equation we solve by rewriting with the same base. So 27, it is 3 cubed, and then everything is to the power of x minus 2. 9 is 3 squared and to the power of x. Look here, when we have exponential expression raised to a power, what do we do with these exponents? We multiply them. Remember the formula, a to the power of m raised to the power of n. What do? We multiply the exponents. A to the power of m times n. This is what we're gonna do here. So 3 to the power of 3 times x, 3x. 3 times negative 2, negative 6. On the other side, we have 3 to the power of 2x. Look, we got the same base on both sides. Since the bases are the same, we set the exponents equal. So we have 3x minus 6 equals to x. Look, we had an exponential equation and now we have a linear equation. What do? We subtract 2x from both sides in order to collect the variable on the left. We have x minus 6 equals 0. What do? That's right, we add 6 to both sides. And our x equals 6. This is our answer. So even though we had different bases on both sides, we were able to rewrite with the same base 3. Then, since we had the bases the same, we set the exponents equal and we got the answer 6. Now let's look at our second equation. This equation we solve by taking the logarithm of both sides because we can't get the same basis. So first thing we do, we add 3 to both sides, right? In order to isolate the exponential term. So we have 4 to the power of x plus 1 equals 15. So we are gonna either take the common logarithm or the natural logarithm of both sides. But why logarithms? Because logarithms undo raising to the power, and that's why we're gonna take logarithm of both sides in order to bring the power down. But why the common logarithm or the natural logarithm? Because these logarithms are available on our calculator, and that's the great news. I'm gonna take the logarithm with base 10. Okay, it's just my choice. You can take the natural logarithm with base e. So what I do to the left side of the equation, I do to the right side. So I take the common logarithm of both sides. Okay, now this power is gonna come up front here according to the property of logarithms. So logarithm of some base b of a raised to the power. So this power is gonna come up right here, up front, and turns into multiplication. Power times log of some base b of a. So we're gonna do the same thing. This power is gonna come up front. So we have x plus 1 times log of 4, you see, according to this formula, equals log of 15. Okay, so what do we do next? We need to separate, right? We need to isolate the variable. So we will divide both sides by log of 4. So x plus 1 equals log of 15 divided by log of 4. What do we do next? We subtract 1 from both sides, and now x is isolated. X becomes log of 15 divided by log of 4 minus 1. If we leave the answer like this in terms of logs, this will be exact answer. But if we want to know x as a number or as a decimal, we just pick a calculator. I have the buttons for the common logarithm and the natural logarithm. So here we go. Log of 15 divided by log of 4. Now minus 1, and it's going to be 0.95. So our x as a number is 0.95. You see, in this equation, we couldn't get the same base on both sides. So we solved it by taking the common logarithm of both sides. Okay, so I hope this is helpful. If you like the video, show me your like. If you have questions, let me know in the comments what your question is. And take a break, let the concept sink in, and I will see you the next time.